She is the lead scientist for science communication at the UW Impacts Group, or the Climate Impacts Group, and an affiliate assistant professor in the UW Department of Environmental and Occupational Health Sciences. Heidi works to understand how to effectively connect science to decision-making in support of climate resilience. Her scientific career has led her to all 7 continents, where she has participated in research from Alaska and Antarctica to the mountains of Vietnam and New Zealand. Heidi was a physical scientist with the United States Geological Survey in Colorado and has developed numerous educational and communication products for NASA, the National Science Foundation, GNS Science, and the Exploratorium. So we're excited to have Heidi with us still to now move into another presentation on the sort of latest projections for climate impacts for the Northwest.
Righty. Okay, you're probably all tired of my voice by now. So hopefully some more interesting content, and welcome to those of you who maybe have joined this track. I don't know if hopping around is allowed, but if it is, welcome. And I'm going to provide you with an overview of some of the impacts observed and projected in the Northwest. This is generated from work at the Climate Impacts Group and colleagues around the state and region. And I'm also going to give you a bit of context on mitigation targets and some of the, hopefully some useful information around the sort of broader narrative and conversation that's occurring in the policy space around our targets for warming out into the future. And these are primarily from the Intergovernmental Panel on Climate Change. So we've done some syntheses of their reports. And I'm just going to hopefully provide you with some useful information about mitigation as well. And this hopefully dovetail into some of what Chad is going to talk about or provide some of the global context following this. So I won't belabor the point. So many of you already know this, and you heard from the introduction. I'm an earth scientist who now is working in the Northwest to understand and help communicate about the relevant climate impacts and how it is that we prepare for the changes we've set in motion through our activities. I have spent a lot of years, more than I'd like to admit, studying past climate in particular, using things like lake sediments and ice cores, which provide us with some of the best evidence we have for how our activities today are well outside of the range of natural variability, particularly in the rate and amount of greenhouse gases that we are emitting into the atmosphere. So I've helped collect ice cores, which provide us with direct evidence of past atmospheric concentrations. And we know that today we're sitting around 416 parts per million of CO2 in the atmosphere. We haven't exceeded that amount in at least the last 800,000 years, and that's direct evidence from ice cores. And we look at geologic records, that extends back to somewhere closer to 3 million years. So what we're doing today is certainly altering our planet. So many of us did this exercise at the top of the first talk, so I won't again, but just revisiting here this planet that we call home that we're talking about and how we have altered it. So when I see a picture like the Earth, it's really hard to comprehend the scales at which we are causing change, and causing change well outside of the range of natural variability. So this human-caused climate change is often, when I step back, really hard to think, and it's hard to say, you know, my activities or our activities have fundamentally altered the inner workings of the planet and our planet's climate, and that is true. We know that from observed atmospheric CO2 and measured global mean temperatures, so these are temperature records aggregated from things like ocean buoys and satellites and just good old weather stations distributed across the landscape. We have seen the global temperature increase, the global mean temperature change by 1.8 degrees Fahrenheit since the late 1800s. To put this in context, we have our policy targets, we are trying to not exceed 2.7 degrees Fahrenheit of warming. And so we are already 1.8 degrees Fahrenheit globally on the way towards that target. And this is synthesized from a range of national measurements of temperature. Climate change is also happening on scales that are less difficult to comprehend, and those are the ones happening in our very own backyard. And this is really what the Climate Impacts Group is focused on, is understanding how that global change is manifesting across our landscapes and the places and things that we care about. So I won't belabor this either because I've already gone over this, but we at the Climate Impacts Group really work to make global science locally relevant and actionable. So making science both useful and used in support of building climate resilience across the Pacific Northwest. We have a range of global impacts that we hear about in the news that are highly concerning. Things like global mean sea level rise of 6.3 inches has already occurred from the year 1902 to 2015. We see the Antarctic ice sheet losing mass 3 times faster in the last decade than it has in the late 1990s to early 2000s. And so we see these range of really disturbing global impacts. But we see those things also show up on our landscape locally. So Washington glaciers are shrinking. This is what this has been documented. Sea level is rising across Washington coast. In most places, sea level rise is rising. We have a very interesting coastline. In some places, sea level is actually falling, like in Nia Bay, where the geologic setting is currently offsetting global sea level rise, but we expect that to be overprinted by a global sea level rise by mid-century. I can provide you with those projections if you're interested. We see our spring snowpack declining and so on and so forth. And so I'll unpack some of these specifics, but we really work to take that global science and downscale it and make it useful at a regional actionable scale. So what have we observed in Washington state? Lock in step with the global temperature, the state, on average, of course, when we start to break up regions in the state, this number differs, but when we look at Washington state as a whole, since 1900, the average annual temperature has risen by 1.8 degrees Fahrenheit. So we see that warming occur. We see our frost-free seasons lengthening, and so many of you on this call, that's probably, you know why this is meaningful, and this is important, particularly when we think about agriculture. Our frost-free season is lengthened by 16 days. This is relative to 1901 to 1960, so this is a change we've already observed. Our peak stream flow is occurring up to 20 days earlier on average. This is specific to the Puget Sound, but again, these are already observed changes that are occurring across these systems. Regional glacier area is in decline. This is the percent decline on some key mountain glaciers that we care about in our region. This is over the last century. For example, Mount Adams is at a 49% reduction in glacier area. Our snow courses, so this is where we measure snowpack across the landscape, 59% of them in Washington state are showing decreasing snowpack, and this is for records at least back to the 1950s, so these are robust sample sizes. At the Seattle tide gauge, we've measured 8.6 inches of sea level rise since 1900. This sea level rise is primarily the result of the global oceans warming. As we add more CO2 and therefore more heat, the ocean's absorbing a majority of that heat, and as water warms, it expands. And so we are already measuring that change in sea level rise. And so this doesn't yet, a majority of this number does not represent what we expect in terms of the contribution from melting of our global ice sheets in Greenland and Antarctica, as well as changes in things like our regional glaciers and loss of that water reservoir. That's very, very minor relative to the global ice sheets, but future sea level rise will be bigger than this, but we are already seeing our ocean level rising. We see the Puget Sound in particular. Ocean acidification from human-generated CO2 is changing the chemical composition of our surface waters and is already posing challenges to things like our shellfish industry and our fisheries. So these are real-world, here and now impacts. Years like 2015 serve as important benchmarks for thinking about what future climate might feel like and might look like in our area. So 2015 was a particularly warm and dry year. Our snowpack was 70% below normal, so very dry and very warm relative to the pre-industrial. And this is the climate that we expect to see around the 2050s. So 2015 is sort of a postcard from the future in some ways. But what's important here is that we can see when we shift these things like our snowpack and our average temperature, we see immediate responses and things we care about, negative consequences like 2015 being our most severe wildfire season in Washington's recorded history. Over 1 million acres of Washington state land was burned. We saw impacts on agriculture from major crops with reduced yields and economic losses. We saw impacts on winter recreation. Some of us may not care about skiing, but other winter recreation was impacted to the low snowpack. And importantly, things like winter recreation revenue are important for maintaining some of our green spaces and state-funded properties throughout the year. So there can be knock-on effects from these impacts. So this is giving you a glimpse at what future climate might look like beyond just say warmer and drier, less snowpack. We can see it has real-world meaningful consequences. And so what do we expect the future to look like? And then this comes into our climate projections. So when we project climate, we're using multiple different global climate models that get downscaled to regional climate models. And so I'm happy to provide more information. I have a slide deck about global climate models and regional downscaling. But important to note is that we never look at one model alone. We're looking at ensembles of models because different models capture the physics of Earth's climate system better. So some have a different focus, or they can model a particular impact, like say precipitation or albedo, better than other models. And so we're always looking at ensembles of models, results from multiple models, and looking at their averages or different modes. So just keeping that in mind, that when we talk about projections, we are using multiple ensembles of models. So when we look at projected change in summer, this is a Seattle Times graphic from Climate Impacts Group data that is showing different greenhouse gas emission scenarios. So low is if we emit less than we currently are. High emissions scenario is showing is for a continued high trajectory of emissions. And you can see that the range of possible projected temperature changes is quite wide. And we can look at the averages. The left panel is showing you the projected warming in the summer months across the Pacific Northwest, with the average on a high emission scenario sitting around 6.5 degrees Fahrenheit warmer in the summer on average. If we look at annual warming across the Pacific Northwest, an average year by mid-century, so this is for the 2041 to 2070s, so we commonly refer to that as around the 2050s. The average year will be about 5.8 degrees Fahrenheit warmer for our region, and that is on a high emissions trajectory. So hotter summers ahead, basically warmer conditions. And we essentially pick, we get to choose because we get to, in effect, by we, I mean the global we get to determine which trajectory of emissions we're on. When we think about climate change in the Northwest region, I think if you wanted to summarize it in just a couple of lines, it would be warmer, wetter winters, hotter, drier summers, or more water when we don't need it and less when we do. So we expect, models are showing around a 22% reduction in rain during the summer months. So these are our characteristically dry period already, but even drier. So hotter, drier, and summers, and warmer, wetter winters. We see this is a projection showing historical summer water deficits, and I'm happy to show you, provide you with the source of all of these data. They're in our State of Knowledge report that the Climate Impacts Group produced. This is showing you the Puget Sound in particular, and this is showing the change as inches for a moderate, so sort of a medium emission scenario, showing that the summer water deficit in some regions is going to become sort of 4 to 5 inches greater than the historical average. And again, I'm happy to show you these. It's hard sometimes to see these data, particularly in a GoToWebinar platform. By the 2040s, summer stream flow is projected to decrease by around 19%. This is particular to the Puget Sound, and this is for a moderate emissions scenario. So this is somewhere splitting the difference between that high and that low emissions scenario. When we think about water, which is a great iconic feature of our region, we are expecting to continue to see more of our precipitation falling as rain. And so the area where snowpack is accumulating will become less and less and less as that freezing level goes higher and higher in the mountains and elevation. And so historically, we can get snow in these lowlands. We are seeing that line shift further up in elevation, and we are anticipating much more of our winter precipitation to be falling as rain rather than snow. And that changes the dynamics of our river systems and exposes us to things like increased flood risk. We are expecting snow melt, so what does accumulate in the mountains to shift. That peak melt should be shifting about, on some cases, a month earlier than the 20th century average. And so this poses big issues for how we manage our water for important applications like agriculture, but also for, say, how we manage things like hydropower. This is shifting the curve of our hydrographs, and I will show you that here. I'll give you an example from the Yakima Basin. When we look at this on a watershed basis, so this is looking at the greater Northwest region, the little boxes are representative of watersheds. The green color represents those watersheds that are dominated by rain. So the precipitation experiences is predominantly rain. So these are lowland watersheds. Transitional watersheds are those that experience both rain and snow. And then snow dominant are obviously those that are characterized primarily by snow. So this is showing the ratio of snow water equivalent to precipitation in our winter months. And so what is important to take away from here is if you track your eye from the historical period towards the end of the century, around the 2080s, you can see that green color overtaking a huge portion of the map, including those watersheds that are coming off of the central spine of the Cascades. And you can see that we are shifting away from these snow and transitional basins to more rain dominant basins. And that's capturing that change that we expect of less winter snowpack and more rain in the winter months. You can see that the upper part of the Columbia retains its snow dominant nature, but this is fundamentally going to change water, our experience and relationship to water across the landscape, particularly in the winter in the future. And this change is for a medium emissions scenario. So this again is splitting the road there kind of between the high and the low. So our wintertime stream flow, as a consequence of this shift in our wintertime precipitation, as well as an expected increase in wintertime precipitation, is going to shift our stream flow and increase it by around 22%. So fuller banks in our winter months for our rivers. And we can see this captured in a hydrograph. So this is basically the water cycle for a river. So we're looking at the Yakima Basin, so the Yakima watershed. This is showing the amount of water in the system over time from October to September. So the black line is showing you how much water, the amount of flow in the system over time. This is based on historical measurements. So you can see there's a slight uptick in the winter months when we first get our winter rains. We see snow melting out at that big peak. This is our summer snow melt. So around June, we see the spring snowpack peak, and then a slow trickle out of our snow as the summer sun melts our snowpack, and it slowly drains out of our system until we start the next cycle over again. So we see that occurring around June. This is what happens under a medium emissions scenario. So this is the 2020s. So we need to now assess how well our projections have repeated this or reflected this projected change. So that's work we can start doing soon. once we have measurements from the next several years. But you can see that the curve is expected, is bending, right? It's bending upwards in this case, and that our peak is occurring earlier in the year. There's more water available earlier in the year. We can see this curve as we march towards mid-century to continue to flatten, so that summer, that late spring snowpack melt is basically disappearing, and our curve is turning and less to a camel and more of, I don't know, some single humped animal. And here we are, we have a single humped camel with our peak flow occurring somewhere in the winter months around January or February. And so when we previously needed our water, right, when we need our water is this red bar. This is when water is needed for irrigation, for in-stream flow, for salmon, for hydropower production, and so on and so forth. We can see that that water is not there when we previously needed it. And so this is a challenge that folks are working to address, but for many of you probably know, we have very complicated water rights and water issues in our state. And so this is an important change that will touch many of our lives, whether we know it or not. And so this is posing a real challenge to a range of folks responsible for thinking about water on our landscape. By the 2080s, our wetter days, so these are our winter rainfall events, are expected to actually get wetter, so to increase by 22%. So more extreme precipitation, posing challenges for things like flood management, as well as just holding that water in certain places, so reservoir management and just getting rain off the landscape. We see as a consequence of shifting this curve in our hydrographs that our average river temperature, so our rivers are expected to have less water in them in the summer, they can warm up more easily. And so we are needing to think about how to create cold water patches, cold water refugia for things like salmon, which require stream temperatures to be cool enough to not be stressed. And so as we have less water, it's easier to heat up. And so there are some great places and opportunities for restoration and conservation to address these issues. But this is something we need to start preparing for, is our warmer streams and less stream flow. Rising seas, for those who are touched to work on or have a connection to coastal lands, rising seas are going to accelerate erosion of areas. So it's not just about water inundating a space, it's actually accelerating erosion in places that are already vulnerable. This is a picture out in the San Juan Islands, and surge causing beach erosion, reduction of important habitat, and obviously posing some challenges for property owners who live along the coast. And for those of you who are concerned about wildfire, we do expect more and bigger wildfire on both sides of the Cascades in the future. This is an active area of research. There are a few great funded projects that are underway right now to better characterize wildfire risks on the west side of the Cascades. But the long and short is that we expect by the end of the century, significantly more area burned by wildfire. There are lots of caveats to this, in that there have to be trees to burn, but we expect more and bigger wildfire in the future. And we do know from observed records that there is a strong anthropogenic fingerprint on observed wildfire, particularly the size of wildfires since the late 1980s, meaning we can see an anthropogenic signal from climate change in the area burned across the Western US. So that is to say that climate change has an impact on wildfire already across the Western US. And I'm happy to point you to those papers by John Abatsoglu at the University of Idaho. And so again, how we feel climate change depends on our mitigation and our adaptation. So this is our preparation and our prevention. So what we experience ultimately depends on these two things. And the choice is ours. So we still are sitting in a place where our behaviors and our actions today matter for the future. So folks have already seen this, but this is showing us sort of the spread in possible futures for temperature change out into the future, so out to the year 2100. The red line is showing us a high emissions scenario, And the blue line is showing us a significantly reduced low emission scenario. Many folks would say that the RCP 2.6, which stands for a representative concentration pathway, this is Intergovernmental on Climate Change, this is global modeling jargon, RCP. In essence, this is showing you the low emissions pathway, and many would say that we can no longer achieve that, that we've exceeded that. I will leave that up for discussion, but right now we are closer to this RCP 8.5 trajectory, where by the end of the century, we could see a temperature change in excess of 8 degrees Fahrenheit. The future, again, this uncertainty is around us. So that spread in possible futures is because we do not know what the emissions trajectory we will be on in going out into the future. And every year, particularly in this decade, matters for where we land on these trajectories. So our actions now most certainly do matter. We could have done more sooner, yes, but that doesn't mean we shouldn't do anything now. So it has never been more urgent for us to think about how it is that we are going to reduce emissions to therefore hopefully reduce the impacts that we will experience from a warmer world. So when we look at emissions pathways and how we get there, this is in particular to the context of reaching our global policy target of avoiding 1.5 degrees C or 2.7 degrees Fahrenheit warming. Emissions, global CO2 emissions need to fall to net zero by mid-century. So this means basically we are going to continue to emit, but we take out as much as we emit. And actually we reach zero. So we can't emit anything in essence to avoid this warming. There are multiple ways we can get there. So this is modeling of CO2, so how we need to reduce CO2, how we can limit that warming to that 2.6 degree Fahrenheit target. This is all these squiggles represent different changes in both CO2 being removed, which is required in all of these cases, as well as the different combinations of fossil fuel reductions, how much renewable, how many trees we plant. This all goes into these different pathways. And so we can get there many ways, but we have to get there quickly. And so you can see that in any of these cases, to reach this global policy target, we need steep near-term reductions, and we need basically negative emissions through the removal of CO2 from the atmosphere. So I'm going to switch modes here a little bit into motivational because I often have to find motivation amidst the overwhelm, because that seems really challenging to achieve that. So this timestamp, 2 hours, 31 minutes, and 40 seconds. Does anyone have an idea what this represents? You can type it in the chat box. And I can't see the chat, so if a moderator sees it.
Not seeing anything.
Any ideas? Okay, this is how long the moon walk was that Neil Armstrong did. He spent 2 hours, 31 minutes, and 40 seconds on the moon. Seems like a long time if you're the person actually walking on the moon, right? But it's not a lot of time to do something so monumental and that basically changed what we thought we could achieve as human beings, right? We sent people to the moon and we worked for over a decade to get them there, to do that, to put their foot on the moon. I mean, I can't even comprehend it. It's just so unbelievably cool. And we so often see that single footprint, right? That this was achieved by one person. And we know there were 2 people on the moon, and then one flinging themselves around in orbit, hoping to get back and save these people. But never mind, a technological feat and so incredible. But it was something that was achieved by many, many people And it took them over a decade to, quote, pull it off. And those are Neil's words. It took us a decade to pull it off, right? For those 2 hours, those 31 minutes and that 40 seconds was over a decade of hard work by thousands of people in order to pull it off. And in terms of climate change, we have just over a decade to pull it off, right? And there's a way more consequence than 2 hours on the moon, right? This is what our lived experience will be on this planet, depends on our actions over the next decade. So the budget for a 66% chance of avoiding that 1.5 degree C target is 10 years of current emissions. That means we can do what we've been doing for 10 years more. And that's it. So this decade counts. We are inching our way closer and closer to that 1.5 degree C target. And so for those of you who have hear in the news things like we have 20 years left or 10 years left, or these statements originated from this particular plot from the Intergovernmental Panel on Climate Change Special Report on 1.5 degrees C. And what it is showing you is where we might cross that threshold of 1.5 degrees C target with our warming, with our current warming. So this is just drawing a line forward from our observed change when we might exceed that 1.5 degree target under our current warming rates. And that puts us somewhere around the 2040s, mid 2020s to mid 2050s if we look at that range. And so this is the sort of narrative, this is the narrative we've heard, particularly around the Green New Deal, is derived from this plot, and it's showing you that we are going to exceed this target and therefore experience incredibly negative consequences of climate change soon if we don't act. And we care about 1.5 degrees C for a lot of reasons. This is pulling numbers again from that report, showing you the difference of the impacts if we warm the planet by 1.5 degrees C or 2 degrees C. So that difference of that 0.5 degree Celsius difference. So if we overshoot that target and we continue warming, we are experiencing 2 billion more people will be exposed to heat waves annually. We will see significant reductions in global corn harvests, declines in fisheries, almost basically a complete loss of our coral reefs at that 2 degrees C target. It goes on and on, right? People exposed to drought each month goes to 76.1 million more people. So the consequences of our actions are incredibly meaningful when we look at it in terms of the impacts on people, on food, on our health and well-being, on water, right? So this is why we care. This is why people are screaming from the rooftops that we need to do more, because the impacts get worse and worse and worse, right? They're already not great at 1.5 degrees Celsius, but they continue to get worse. I figured someone would probably ask, so I'm adding this in here, a note about COVID and the rapid change in our global economy and our global demand on energy. So the International Energy Agency has forecast the CO2 impact of this crisis, right? So this massive change in what humans are doing and how our economies are operating globally, that emissions could fall by somewhere around 8% this year. So we're sitting at that number, and I encourage you to go to Carbon Brief and read their article. They're always updating these models as new ones come out. So I encourage you to check that out to stay up to date if you're interested in how the COVID crisis is going to translate to impacts. And so this is referring specifically to emissions, not to concentrations in the atmosphere. Those are two different things. But in the context of emissions, they could fall by around 8.8% this year. And to achieve that 1.5 degrees C above pre-industrial temperature, right, we need emissions to fall by around 7.6% every year this decade. So that just gives you context for the scale of action required. I don't think anyone would advocate that a pandemic is the way we get there, and that this complete fundamental, I mean, this is not how we do that. But this is in order to give you a sense for the scale at which we need to act in order to achieve this goal that we've set out in the Paris Climate Agreement, and how fundamental it is that we do it now. So the question is, how can we pull it off? There are lots of actions that we can take part in. There's adaptation as part of this story as well. And we can talk about this maybe in the discussion. But to go back to what we thought was impossible, this moonwalk. Well, actually, we're gonna talk a little bit how we do this, and I think hopefully you can see yourself in here somewhere in terms of what you might be able to do to contribute to this grand challenge that we face. So how we address climate change and these fundamental changes we know we've set in motion, it's really important that we connect dots between individual actions, which are important but cannot occur at the scale that is required to address this global challenge. We need to connect those dots to the institutions we rely on and really ensure that a climate change lens, both in the context of mitigation and adaptation, is being passed on to people who are making decisions, and we're using it to consider how it is we do climate smart conservation and restoration, how it is that we build climate ready roads, bridges, transit systems, how it is that we ensure we are going to be able to provide reliable water and manage our wastewater, how it is that we have responsive health systems, that we have appropriate emergency response, and that we're protecting and maintaining important things like cultural assets, ecosystems, the list goes on and on. But the absence of climate from these conversations and from these things, it's not entirely absent, but the need for it to be part of this, part of all of these decisions that we're making, has never been more important. Because this is where we can start to make change at scale, both in the context of preparing our region for those changes we set in motion, and for thinking about where is it that we can reduce our mitigation and where we can reduce our impacts through emissions on this sort of global climate system, right? And it is that we need to start making change at scale in order to achieve these really important targets for limiting global warming. So my colleagues Nevis and Nassim at the UW said this. I wish I had said it, but I'm going to quote them here. But basically, we need to adapt to climate change even as we seek to mitigate it. So it's not an either or. We don't necessarily all need to be doing all of them, but we need to be thinking about it as a balanced equation, right? We've set Earth's climate change. We've set climate change in motion. So we need to prepare for those changes that are coming down the line. We also have an opportunity, I think, and an obligation to think about how it is that we mitigate it to avoid the worst of the worst consequences that can emerge as we continue to warm the planet. So the good news, and some of you already have seen some of this, but there's a desire for action at all levels of government. And I see so much hope in here because this is not what I expected from these polling results from last year. I did not expect this in 2019, that the American population wants to see the federal government, state governments, and local governments and communities doing more to address and prepare for climate change, right? People want to see this being done. They want to see it being done in the systems and where it can be done at scale. 64% of adults in Washington want local citizens to do more. So this is that individual thing. People want to see individuals engaging and doing more to address this issue. And 56% of adults in Washington want local officials to do more. I think we could see more on this number. We can see this number go up. But the point is that there is, in general, an interest in doing climate-related work across institutions and scales that matter and that will help shape our future as we live in these communities. And so I think there's a real opportunity, depending, who you are, your connection to leaders and local officials. I think these are really powerful numbers because there is a documented perception that the public doesn't want the government doing anything, or that people aren't really thinking about this issue and someone else will take care of it. But if we can connect decision makers and elected officials to people and to data that show that people want more being done, that is a way to help inspire or further action in this space. And again, for those of us who live in the Northwest, and I'm sadly leaving, is that the Northwest leads the nation in the breadth and depth of attention to building climate resilience. And this is happening in all sorts of places by unexpected characters who are doing work and pushing hard to change how their institutions act, to change policies, or to simply get a climate lens passed over fundamental work like how we manage our toxic waste sites across the state. Seems like climate change should be part of that, but it wasn't until recently that it became a requirement to start thinking about how climate change, like sea level rise and flooding, will be impacting and potentially, basically how we manage our toxic waste. I think everyone would agree that it's important to, none of us want toxic waste floating all over our landscape or in our oceans, right? Or in our waterways. And so there are people, and often individuals, who are at the heart of these stories, these success stories, and who are really fundamentally changing how our institutions operate and are leading towards success. So there's no question that today we need to take a giant leap for humankind right here on our very own planet. We don't need to go far afield to do this. And I will lean on Neil, who is apparently a very humble man, who said after the moonwalk, when you have hundreds of thousands of people all doing their job a little better than they have to, you get an improvement in performance. And that's the only reason we could have pulled this whole thing off. I think that's a very appropriate quote if we think about it in the same context of our planet and the scale of action that's required. So when we have hundreds of thousands of people all doing their jobs a little bit better with that climate lens, with investing and thinking about how their actions today will shape tomorrow, you can get an improvement in performance. And in this case, we can get an improvement in both how we mitigate and we prepare for climate change. And it is only through doing this that we can pull this whole thing off. And so that involves all of us. So my question to you is, how will you help us to improve our performance so we can pull this off? I hope I've communicated the imperative. And I'll just give you a few examples to maybe help you think about what that looks like. As we move forward and make a climate smart and climate ready region, there's things we can do that are going to enhance our abilities to address this challenge and to confront it head on, and to do it in a way that's equitable and is not leaving people behind. And we do this by improving coordination and collaboration. We do this by thinking about how different ways of knowing and what we define as knowledge, making many ways of knowing valid and heard and part of the conversation. We support and engage in meaningful deliberation and deepened engagement around how we achieve these targets and who they impact. We support climate change decision-making in unexpected places that might be right where you work or in your community. And we build governance capabilities at a variety of scales. And we know from national polling that people want to see that happening. So how is it that we can, through our own work, in our professional capacity or as individuals, help build capability and capacity in places where we can start to have this work happen at scale? And so I'll leave you with this, the royal we, right? We all choose, and to, an extent that we includes you. And I acknowledge that we all have different abilities to contribute to solutions at scale, and we all are related through different power structures and so on and so forth. But we all live on this amazing planet, and we are all changing it. And so the solutions all also involve us. And so that large we also includes you to the extent that you can and are able and willing. And so I will leave it at that. And we do have time for some questions. I'm sorry, my daughter is screaming in the background. But I'll pause there, and I'm happy to take questions or concerns offline as well. But my hope is that you have some fodder for understanding why this matters in Washington State and what it is we need to do global we to achieve these targets, and why that is so fundamentally important that we start to do something now to prepare for a world that is being fundamentally changed by our actions, but we also get to choose the extent to which we change it. So there's a real opportunity there. And I will stop there.
Thank you so much, Heidi. I think that was a great presentation. I really appreciated the sort of local context of what we're facing here in Washington State, but also that context of that sense of time frame and that sense of urgency, and why actions are needed in the next decade here. And I also think conservation districts are uniquely positioned to engage with climate change in a unique way because of the interactions that we have with the public, with people on their landscapes, landowners, farmers, on their landscapes, dealing with their natural resources. I think we have a unique position as CD staff to engage the public in really unique ways around this issue.
Yeah,
so thank you so much.
Yeah, I think you have a really important role in helping us understand how climate change is or is not part of the conversation, and importantly, why it matters and what those stories are and what the lived experiences are. I think you're all very well positioned to play an incredibly important role in advancing climate resilience across the state of Washington. And I wish I had an opportunity to be with you all in person and learn from you, importantly, because the work you do is so important.
Yes, thank you. And I will make a little plug for a presentation later today as well, because it fits in so well with all of this. We're going to, SCD is going to be presenting about their climate resilience work there that we've been doing with the Ag Resilience Plan. And so that is kind of a little bit of an example of some of this work that CDs can do. So at that, I will go ahead and turn it over to Jan to let us know if there are any questions.
Yeah, we have one question kind of related to that. Tova asks, are there some of the graphics and slides available to CDs to use in our outreach from your presentation, giving credit where due, of course?
Yes, I'd be happy to share slides. I have to make a few institutionally required tweaks, like adding our logo, but I'd be more than happy to pass along these for you to use as you wish to help get out the word.
Perfect, thank you. Not seeing anything else in the question box right now. Remember, you can raise your hand and I can call on you directly, or feel free to type something in to the question box and we can have Heidi answer those.
Yeah, and I can just add on as far as resources and visuals, if there are other questions that come in. At the Climate Impacts Group website, for some of our newer reports, say synthesizing some of the larger Intergovernmental Panel on Climate Change reports, we have made all of our graphics individually downloadable with captions, as well as in the PowerPoint format. So if there's a desire to take those graphics from these reports, one is called No Time to Waste, and the other one is called Snow Lines and Shorelines, which include those infographic-y type graphics I showed you. Those are all available freely for download and for you to use and repurpose as you'd like for your engagement efforts.